In this section of chapter 3, the first section, we'll talk about the complex number system. So some functions have zeros, also known as x-intercepts, that are not real numbers. So normally if you see that there's no solution, we say no real number solution. All right. The complex number system is used to find zeros of functions that are not real numbers. And what you'll see visually if looking at a graph of a function, if it doesn't cross the x-axis, it has no x-intercepts, and thus no real number zeros. So for example, I drew a little graph here of the function x squared plus 1. All right, and if we look at this graph, we can see that, and if you just did the transformations lessons, remember you can take the graph of x squared and the plus 1 raises all the y values up 1 unit. So it won't cross or touch the x-axis at all. All right, in which case there's no x-intercepts and there's no zeros here. If we were to algebraically solve this for zeros, right, you recall would take your function x squared plus 1 and set it equal to 0. Right, this is what we do to solve for x-intercepts, or zeros as they call them for short. You would subtract 1 from both sides of the equation to isolate the x squared. And now you have something that's not possible, because to solve this, recall you would take the square root of both sides of the equation using what's called the square root principle. Some of you may want to look that up if you don't recall solving equations this way. And then the square root of the x squared, any squared variable, is that variable. But now we have something that provides us with no real number solution, because no number times itself can equal -1. So we can't take the square root of -1. And this is a situation where we don't have a solution that's a real number. And so the complex number system gives us a way to solve this. All right, in the complex number system, the imaginary number I is equal to the square root of -1.